right, so when you're looking at these rational expressions, you've got to ask yourself what the common denominator be. So here in this case, I am going to add my or subtract my fractions, and the denominators are identical, yes? And so what is the rule that we do? What is our answer going to be? 2 over 2x. You always want to make sure that it's in totally reduced format. Is there something that I can reduce everything in the numerator with and everything in the denominator? 2. So if I cancel out a 2 here, what do I get? And I get a 1 over here. So this is 1 over x. What's 7 over 2x minus 5 over 2x? You want to come closer, Rachel? Yes. Is there an equation? Can I solve? If there's not an equation, if it's not set equal to anything, then how can you solve and come up with the value for x? If there is no equal sign in this problem, don't put one in there. Don't set it equal to 0, because you've just changed the entire problem. Okay? All right. Are my denominators the same? You want to sit? No. Oh, okay. All right. Are my denominators the same? So we're going to subtract the numerators. 4x minus 1x over x minus 2 is 3x over x minus 2. Is there something that I can reduce both the numerator and the denominator with? No. That x isn't going to come out. Would you agree? So it's my final answer. All right, here they come a little bit harder. When it's not so obvious, the first thing you always want to do on these harder ones is factor the denominator.
Just the denominator?
Yeah, because the denominator is what you're worrying about. You don't care about the numerator. The numerators don't have to be the same. The denominators do. Okay? So that means what can I factor out of this denominator? Just a 5? A 5 and an x. And what does that leave me with? X minus 2. So remember, common denominators are created by factoring and then making sure that all denominators have the same factors in them. Okay? So this denominator is 10x squared. This denominator is 5x times x minus 2. Agreed? All right, so if I give you a 10 in the denominator and a 5 in the denominator, what would your common denominator be? Okay, that means all of these need to have a 10 in there. If I give you an x squared, which is a factor of my first denominator, and an x, which is the factor of my second denominator, what would be the common factor? Okay, so what would be my common denominator, though? X squared. I always have to go up. I can't ever go down. So I have an x squared here and I have an x here, right? So I have to have x squareds in both. Do you agree? Now, what's the other part that's missing? Right, they both need an x minus 2. I'm looking at my denominators. This is 10x squared. This is 5x times x minus 2. Okay?
Can you just bring x minus 2 over?
Well, hold on. I'm not done yet. Okay? I'm just identifying what my denominators have to be. I need a 10 in both of the denominators. I need an x squared in both. And I need an x minus 2. I'm not just doing it. Let me finish. And I think I'll answer your question. I'm not just placing it in the denominator. Okay? In this first fraction, if I need 10x squared times x minus 2, what already exists? So what do I have to multiply the numerator and the denominator by? X minus 2. So I'm now going to have a 3 times an x minus 2. So I'm replacing the numerator what I added to the denominator. Would you agree? Okay. Now, I had 5x and x minus 2, and I went to 10x squared times x minus 2. If I go from 5 to 10, what did I multiply by? 2. If I went from x to x squared, what did I multiply by? And then I already had the 2x already up there. Would you agree that was already up in the top? Well, let's think of our math. Okay? It's 4x squared because I'm just multiplying across, correct? So this is going to be 4x squared over 10x squared times x minus 2. And this other term is going to be, we're going to want to distribute. What's that going to give me? 3x minus 6 over 10x squared times x minus 2. So now my denominators are the same, aren't they? So what do I do with my numerators? In this problem, I'm supposed to add, right? And we're going to order it. So we're going to put 4x squared plus 3x minus 6 over 10x squared times x minus 2. You can keep that denominator in factored form, but work out and simplify the numerator. Okay? Well, I have to have a common denominator, and I have to go up. I can never go down. So if I'm looking at a factor of 10, I'm always looking at what my factors are. What are the things that I'm multiplying? In this side, I was multiplying a 10 and an x squared. In this side, I was multiplying a 5, an x, and an x minus 2. Okay? So I have a 10 and x squared. I have a 5 and an x. That means I need a 2x in both the top and the bottom. I needed an x minus 2 in the bottom, so that means the top and the bottom over here are missing the x minus 2, so that's what I multiply by. I'm always going to go up, just like in this problem up here. Between 18 and 72, I didn't say 18 was my common denominator. I had to go up and find the first number that they both had in common, which was 72. Haley, what's your question? It was given to me in this denominator, okay? So when I factored, I figured out I had 5 times x minus 2. I pulled out a 5x from both of these terms. I factored it. And so if I have a 5 and an x, and I need a 10x squared, I'm missing, because I'm multiplying, what am I going to multiply 5x by to get 10x squared? Yeah, I mean, so these are your factoring problems. 10x squared, what was it? No. It's 5x squared minus 10x. If I ask you to factor it, the first thing you always ask is, can I pull something out? What do I pull out of every term? That's where my 5x came from. It doesn't disappear. I went and made this 5x, and I multiplied it by 2x to get 10x squared. Okay? All right, let's try another one. So the first thing we're going to do is we're going to factor 7 over 9x squared plus x over what? What am I going to pull out of every single term? And what am I left with? X plus 1. X plus 1. All right, Haley, I'm going to put you on the spot. Now, one denominator has 9x squared, right? My other denominator has 3x and an x minus, or x plus 1. So look at this. What am I going to multiply 3x by to get 9x squared? Yep, I'm going to take top and bottom and multiply it by 3x over 3x. So now my denominators have 9x squareds in both of them. You're telling me I'm supposed to multiply this by 3? By what? That gives me 9x squared plus 9x. I can't just arbitrarily add something to my denominators. My common denominators are gotten by multiplying. Samantha? Well, remember, to get a common denominator, don't you multiply the numerator and the denominator by that value? Well, this one, I'm going to be multiplying by 3x over 3x, right? That's how I'm getting the 9x squared down here. Right. No, this one just stays, right. But I'm not done yet because I haven't gotten my common denominator yet. So, but I still have this x plus 1 sitting down here, don't I? As one of my factors. So then, you getting it now? Multiply top and bottom by the same thing so that I have 9x squared and x plus 1. So that makes this numerator, when I distribute the 7, what? And then what does this one become? Yes. And what am I doing with these two terms? Adding them. Okay? And then, so then my denominator becomes 9x squared times x plus 1, and my top becomes, I'm just adding everything, so we're going to order it, yes? 3x squared plus, yes.
So we have to calculate out basically just like that.
You can leave the numerator multiplied out.
Okay.
Okay. All right, so what's the first thing you're going to want to always do with these? Factor your denominator. All right, so what is this denominator factor to? X plus 3, exactly. What does the next one factor to? Okay, I can pull out, so the first thing you always say is, what can I pull out? So 12 and, okay, so now just look at these denominators. Anything that's multiplied has to exist in the common denominator. What do I need to have in my common denominator? An x plus 3, a 12, and x minus. Now, do I have to square it? Why do I have to square it? Does it appear squared in any denominator?
Oh, but it's there twice.
No, it's here once and here once. So how often does it have to appear here? Once. So that part already exists as the common denominator. I don't have to worry about that. If I had a squared here, if I had a squared on the x minus 4, then I would want to have a squared. Does that make sense? Okay. All right. Okay, so of these 3 factors, this denominator has 2 of those factors, right? Which one is it missing? So we're going to take the top and bottom by 12. And what does that make this first term? Just 12x. Would you agree? Is this making more sense? Of the 3 factors, 2 exist in my second term. Which one's missing? X plus 3. So I'm going to take x plus 3 and x plus 3 in both the numerator and the denominator, right? And I'm going to distribute that 5. Would you agree? And what does that give me here then? Yes. And so if I were to then simplify that numerator, I would get 17x plus 15 over 12 and x plus 3 and x minus 4. Where is there a minus?
Like when you're at the part where it's 12x plus 5 times x minus 3.
It's not x minus 3, it's x plus 3. Better? Really would help you if you would print these out, Rachel. You'd have them in front of you. Yes? Well, from here to here, yes. But how would I simplify this any further? Yeah, I mean, if you can, write the numerator in by combining your like terms. Absolutely. Okay?
You don't have to go farther than that.
There's nothing else I can do, yeah. Okay? All right, so we're going to factor. What's this next one factor to? What's this denominator's factor? X plus 2, x plus 2. Okay, and what is the second denominator factor to? Okay. Katie, you with me? You did it already? Okay. All right. So tell me, What should be in my denominator? The plus 2 squared. So, Emily, this is why it has to appear twice. Does that make sense? Because the plus 2 occurs twice in this one denominator. It's once in this denominator, but twice in this denominator. So I have to have it 2 times. Does that make sense? And then I need the x minus 2. Well, what do I have to add on the left? Yes. So the left one is missing an x minus 2, and the right one is missing an x plus 2. So this is going to be x minus 2 times x plus 1. Agreed? Now this is really you got to be really careful at this point. I got a minus 6 times x plus 2. So that negative 6, I got to make sure I do what? Distribute the negative 6 into both parts of that second term. All right, so I'm going to distribute both the negative and the 6 over here. This gives me x squared minus 2x plus x minus 2. That's what these FOIL out to be. This is going to be negative 6x minus 12. Do you follow that? And so down below, I get x plus 2, and I'd like you to square it if it appears more than once, and an x minus 2. All right, now let's combine our like terms. In the numerator, I don't have anything to combine with the x squared. I have a negative 2x, a positive 1x, and a negative 6x. So what does that give me? And then minus, yes, 14, because I've got a negative 2 and a negative 12. And I got x plus 2 squared and x minus 2. You just got to really be careful about your factoring. And then careful with that negative sign that you don't distribute. Pooja, sit up. Okay, Meg? Because I have a negative 2, a positive 1, and a negative 6.
So you were missing on the left side. You were missing an x minus 2.
And so we had an x plus 1, and I FOILed it. I got x squared minus 2x plus x minus 2. That's my blue part. Better? Okay. All right. So here we go. This is your complex fraction. But don't look at it as one big fraction. Break it up. All right? Is the numerator simplified? Do I have to get a common denominator for the numerator? I'm going to leave it as 5 over x plus 4. And I'm going to simplify that denominator. Okay? I have 1 over x plus 4 plus 2 over x. This is just what we've been doing. What would be my common denominator? See, you can't just add values. I can't. How do I make this x plus 4? I can't add 4. I can't just add 4 to a denominator. I get common denominators through multiplication. That's it. Nope. Yes, it has to be x times x plus 4.
So if you multiply that side by x plus 4, that's like okay.
Yep. Exactly. So my common denominator is x plus 4 times x. This numerator becomes x. This one becomes 2 times x plus 4. Agreed? 2 times x plus 4. Yes? Which then really becomes x plus 2x plus 8 over x plus 4 times x. Agreed? All I did was put it over one denominator and FOIL. Yes? Which really is 3x plus 8 over x times. Now, this goes where in the original problem? Right here, doesn't it? Don't forget, we've got a complex fraction, correct? So this is 3x plus 8 over x times x plus 4, right? So what do we do now? We don't cross multiply unless we have an equal sign. Multiply it by the of what? Right. So what am I going to really be multiplying this numerator by? Exactly. Because we just moved it from the denominator to the numerator by multiplying by the reciprocal. Exactly, because they're factors. We're multiplying, right? So the x plus 4's drop out, which leaves me with what in the top? And what in the bottom? Yeah. But break it down into baby steps. Yes, you will. Huh? You do have to show a lot of work. There's no such thing as a one-step problem. You can work down. Why can't you? Okay, well, whatever you do, however you decide to do it, just show me enough work. Okay, let's try the next one. Okay, I'm gonna go to a different page. This said, what did this say? 3 over x plus 5 all over what? Okay, Haley, 2 over what? X plus whoe? Thank you. Can you be loud? Okay, so the numerator is simplified, yes? So we just have to take the denominator over to the side and say, well, 2 over x minus 3 plus 1 over x plus 5. And get a common denominator. What should that common denominator be? You have to, because you can't add anything to them. They have to be multiplied. So that means this one is going to get multiplied top and bottom by x plus 5 and this one's by, y'all out there? You can only multiply. Right. Okay, let's multiply the top and the bottom by 5. That gives me 5x minus 15. Did that give me anything like I was supposed to get? Right. No. What do you want me to multiply here? By 3? Then I get 3x minus 15. Then I'd get 3x plus 15. But I need 5x plus 15. Yes. Did I convince you? Okay. Okay, so that gives me what in the numerator here? Okay, 2x plus 10, and here? Okay, and my denominator is a product of x plus 5 and? Yes. So then I get 3x plus 7 over x plus 5 and x minus 3. What do I do with this? Right. So now we have 3 over x plus 5 all over 3x plus 7 over x plus 5 and, right. And so I'm going to, I don't. No, I don't. Because, see, we wanted to cancel. Does that make sense? All right. That's why keep the denominators always in factored form. So I'm going to multiply by the reciprocal, right? Which is going to be and what's going to cancel? Yep. And then I'm left with 3 times x minus 3 over 3x plus 7. So you could, yes, definitely, you could tell me that's 3x minus 9 over 3x plus 7. Yeah, can you? Can you take it out of every single term? So you've got to remember to ask yourself that question, Emily. Nothing canceled. The x plus 5's canceled. Why? Because it's 3x plus 5, x minus 3, and x plus 5, and 3x plus 7. Does that make sense, Abby? As long as we're multiplying, we can cancel. I took this denominator. I have 3 over x plus 5, right? Divided by 3x plus 7 over x plus 5 and x minus 3. So I'm taking this numerator and multiplying it by the reciprocal of my denominator. So do you see how I have an x plus 5 here and an x plus 5 down here? Yes? You with me?